Hello and welcome to BlastOne's introduction to water jetting, water cleaning. As far as water jetting, water cleaning is concerned, there are specific standards we follow in relation to water jetting, water cleaning. Those standards are the NACE standard, which is SSPC SP12, WJ1 to 3, and also the Australian standard is 4233. Those standards are specific or relevant to what we're doing as far as water jetting, water blasting and water cleaning is concerned. So the key factor here, or the key word, is water. So what we ultimately are trying to achieve is a clean substrate from the water generated from a particular machine. This here is a mobile machine. Generally these will run up to about 5,000 psi. This particular one is 4,000 psi. It is identified on a tag or plate as far as the machine's concerned in relation to what its capacity is, how many litres a minute it does, which is relevant to what size nozzle we use in that particular machine. So all of that is irrelevant to the output and capacity of the machine. We need to understand what the machine's capability is in relation to what safety procedures and measures we need to take in relation to keeping us safe, doing the job appropriately, and also too, don't forget about the environment in which you're utilising this equipment. So there are consequences in relation to utilising water. Where's the water going? What is the contaminant on the substrate? What is the surface I'm cleaning? Am I getting an appropriate outcome? Is the equipment sufficient enough to do the job? All of these need to be taken into consideration prior to doing any water jetting, water blasting, water cleaning. As far as the environment's concerned, also too, not only the water runoff, but the water vapour, the mist that you create. It can go into certain articles, items that should not accept water, such as cable trays, electrical equipment and so forth. So it's important you understand your environment prior to commencing a job. Do I need to isolate things? Have I read the JSA written to that particular job, specific to that job? And there should be a specific job criteria in relation to water jetting. So understand those criteria prior to starting any sort of water jetting or water cleaning. It's important to remember that when you're projecting a stream of water, water is a conductor. So if you point water at an electrical item, it will travel back up the stream of water, and the consequence of it, you're electrocuted. So that's why it's important. Isolations are in place. Everything is covered in relation to what are the consequences of what I'm doing. There's also a noise factor too. Water cleaning, the gas engine or the petrol engine here, it does have an exhaust noise. Also too, the nozzle in which is selected for this particular type of pressure, it does have a noise factor. So those decibels are relative into what the environment you're working in. So make sure that you are compliant in relation to noise, water runoff, and the consequences of my actions in relation to water jetting, water blasting, water cleaning. What is good about these machines are they're easy to manoeuvre, easy to put in place, and are quite adaptable to different situations. So as far as water cleaning is concerned, the most important thing with these particular machines is the water quality. So I use tap water, or potable water as we call it, so it's drinking water. That's the criteria in relation to clean water. That's how clean it has to be. I cannot set a pump up over a dam and suck the water out of a dirty old dam and put it through this machine, because it is detrimental to the fundamentals of the mechanics within this pump head. So you'll decimate or destroy this machine. So water quality is paramount importance. The way we've set this one up, we put a pre-filter on the tap and then run the hose through. So before I even endeavour to actuate this pump, what I will do is run the water and ensure that it is clean and the filter is not impeding the water flow, because the important thing is these pumps cannot run dry. They can't run out of water. If they do run out of water, it's detrimental to the seals and the pistons and the valves contained within this particular pump. So the pump itself has water coming through it, so it means I need a primary drive. And as I say, in this case, I have a petrol or gas engine. You can have diesel engines. You can have electric to drive that particular pump. The good thing about this particular machine is there is no electricity, because water and electricity don't go together that well. With that, most of these machines where the water flows through, this one doesn't have what we call a reservoir, so it doesn't hold water prior to it going into the pump. So the pump's doing two things. It's receiving the water that you're sending from the main, but also too, it has to rely on that water pressure to maintain fluidity within the pump itself. So with this particular pump, what we need is a good water stream, water flow, primarily because the output of this particular pump is X amount of litres per minute. Every manufacturer will state that this pump has a capacity of maximum PSI, maximum litres per minute. So in this instance, we've got a filter on the main where the water is coming from. But where the water comes in here, there's no reservoir, there's no holding of water. So what could happen is if somebody ran over the hose and pinched the water supply and the pump continues to generate fluid, it starts to starve of any liquid, so the fluidity within the pump is reduced to such a degree that it becomes detrimental to the operation of the pump. It'll actually cook the pump. So in general terms, we have to make sure that the water flow is maintained throughout the operation of this pump. If it starves for water, it can cause what we call cavitation within the pump. So it gets a pocket of air in there, and the pocket of air can be quite detrimental, particularly to brass surfaces, O-rings and so forth. So without a reservoir, it's important we maintain the flow of water. How long would I have if I ran out of water with this particular pump? You only have a few seconds to switch the pump off. That's how quickly it decimates the internal workings of this particular pump. So with all of these pumps, we make sure we've got consistent water flow to the pump, because it has to receive the water. It's not designed as a scavenger pump. It's designed to pressurise the water and send it out to me, not pick up the water and then push it out, because that's two jobs. Primarily, we want it to do one job. So we make sure that it has sufficient water flow. So water quality, filtration of water prior to entering the pump will ensure longevity of the pump itself. You'll notice here that we've also used a mince-up or A-type coupling.